Yeah, so we are supposed to evaluate this integral. We're supposed to evaluate this integral and express it as a gamma function. Now, we're going to keep in mind here that the original definition of the gamma function is 0 to infinity x to the p minus 1 e to the minus x dx, where p is greater than 0. So this is the original definition of the gamma function. Greater than 0. Okay, so we don't have an exponential here. So on a problem like this, what we could do, we could call this e, u. And then with that logic, we would get e to the u equals 1 over x. So I can rewrite it in the form of the gamma function. So x becomes e to the minus u, which makes dx be minus e to the minus u, the derivative, times du, which makes du equal minus e to the u times dx. And so now I can substitute in my original integral. Oh, and let me get the bounds. So if x is 0, u will be ln 1 over 0 plus, to be in the domain of ln, will be ln infinity, will be infinity. And if x is 1, then u will equal ln 1 over infinity, which is equal ln 0 plus, which is equal to 1 over 1, ln 1, which is equal 0. And so now my original integral becomes, which is the integral in the problem, becomes, so the bounds of integration go from infinity to 0. ln 1 over x, I called that u to the p minus 1. And dx was or in that case, lost you there?
Yeah. I gotta reconnect with the CPU.
Oh, okay.
The same password.
Yeah. Okay, so I'm still working it out here. So we've got our dx to be minus e to the minus u du. Okay, great. And at the cost of this minus sign, I could switch these two, so I can put them in the standard form of my definition of the gamma function. So this becomes 0 to infinity u to the p minus 1, and then e to the minus u is just x. So times e to the minus u is just x, but we're gonna leave it e to the minus u so we could match that. So we've got e to the minus u, and we have du. So now everything in terms of u, everything here is done in terms of u. And as can be seen, yeah, this is just the definition of the gamma function. And so this would just be as illustrated by the definition. This is just the gamma function of p. Yeah? How are we doing on that, Ben? We have progress here. You need a hint on how to start, or you get the idea? Hmm?
Yeah.
I would start by labeling ln 1 over xu.
All right.
I would start with that step, and then from there do a substitution to replace.
Because then we can get the dx, and then we get something.
Right. Yeah, so and then finishing up here, so this is gamma function of p. Therefore, the integral from 0 to 1 of ln 1 over x raised to the p minus 1 is nothing but the gamma function of p, whatever that p is. Let me circle this nicely. So we just retain back, you'll retain back the original definition of the gamma function.